same carrier not required at transmitter and receiver. This is the third advantage in envelope detector. Okay, and now if we go with the synchronous demodulation, the next method, synchronous demodulation. Synchronous demodulation. We have to use same carrier at the transmitter as well as receiver. Same carrier should be used both at the transmitter and receiver. So previous two methods, they will work. For mu less than or equal to 1. For mu greater than 1, there is a problem. And hence we go with a synchronous demodulation. It can be used for mu greater than 1 also. And then if you see the output you can have a multiplier, something like S of t modulated signal, then C of t carrier. You can put a multiplier and then followed by a low pass filter. This is the general thing in all synchronous demodulation. We will get the M of t back. And final output what we are going to get here, it will be half AC square M of t, So here we have different cases. Case 1, if carrier C of t different at transmitter and receiver, then output will be half AC cap and M of t. And if both are same, if carrier used at transmitter and receiver are same, in that case we will get output as half AC square M of t. Same AC amplitude will be there at transmitter and receiver because we are using the same carrier. Third case, if there is a phase shift, C of t at transmitter, okay, and receiver differ by some phase shift. Let the phase shift be pi. In that case, output is nothing but half AC square M of t cos pi. And here again, if at all this pi is 0, what happens? And the pi is 90 degrees, what happens? Pi is 0 degrees, cos 0 is 1. If pi 90 degrees, cos 90 will become 0. Okay. And in this case, output is half AC square M of t. And in the second case, output is 0. When that phase shift equal to 90 degrees, output is 0. This is called quadrature null effect. Okay. The transmitter and receiver, they are not using same carrier, and the carrier is having a phase shift. At the transmitter, C of t means, at the receiver, it is with a phase shift. Okay, I will show you the meaning of this. At the transmitter, if carrier is AC cos 2 pi FCT, at the receiver, carrier will be AC cos 2 pi FCT plus phi. A phase shift of phi exists. Okay, they are not the same carrier. There is a phase shift. If that phi is 0, they are exactly same. It comes back to case 2. If phi some angle exists, if it is 90 degrees, then output becomes 0. Cos 90 is 0, so the output becomes 0, and it is called quadrature null effect. Okay, so this point is very, very important. Quadrature null effect means the carrier at transmitter and receiver, they differ by a phase shift of 90 degrees. They differ by a phase shift of 90 degrees. All these are different cases in synchronous demodulation. Synchronous demodulation. Okay. So output equation you have to remember. Output equation you have to remember in synchronous demodulation. Now, what happens if mu less than 1 greater than 1? We will go with mu less than 1 greater than 1. Okay, first two methods, which is square law demodulation and the envelope detection, we will have mu less than or equal to 1, it works. But for mu greater than 1, it doesn't work. Mu is the modulation index. Now, if I add these two signals, I will take a sinusoidal signal. I will take a sinusoidal signal. Let the height be +2 and -2. This is origin, x-axis, y-axis. If I add this with a DC signal, let the height be 5 units. This is DC, 5 units. And the resultant will be a sinusoidal which appears with respect to the DC. With respect to the DC. Okay, after addition, the resultant signal. This is 5. 5 plus 2 is 7. 5 minus 2 is 3. Okay, 5 plus 2, 7, and 5 minus 2 is 3. Same sine wave will jump to another height. Will jump to another height. Okay, and in this case, if this is the message signal, okay, and after modulation, after modulation, the resultant signal will be, okay, both positive and negative sides. This is the outer form I told you. This is not exactly output. And the waveform will be high frequency carrier. Waveform will be high frequency carrier. Okay. The outer will be something like this. This is case 1. This is case 1. Now I will go with another case. If I take case 2, if I have same sine wave, +2, -2, and then let this be added with a DC signal 1, and the resultant in this case will be, with respect to 1, the sine wave will be present. With respect to 1, sine wave will be present. Above the dotted line, 2 units means it is 3. Below the dotted line, 2 units means it will come to -1. It will come to -1. Okay, this is the resultant waveform. And after modulation, if this is m of t, after modulation, if we draw the waveform, it will be something like, it will go to negative side also. Okay, similarly, the lower half, this will go to the other side. There is phase change, phase overlap which is taking place at this junction point. Okay, it will repeat the same direction. It will not be a full waveform. It will repeat the same direction. Okay, something like this. So we will draw the sine wave only at the junctions. Okay, whichever direction it is coming, same direction it will repeat. That is called phase reversal. Phase reversal occurs. And this is for mu greater than 1. And all these previous cases, mu less than or equal to 1. Okay, this is the problem with envelope detection. And if we go with if the envelope detector is having AC cos 2 pi FCT, then the output will be AC in envelope detector. If it is getting a signal 1 plus ka m of t, then cos, sorry, this m of t is only for ka, 1 plus ka m of t, then cos 2 pi fct. In the envelope detector, output will be 1 plus ka m of t, 1 plus ka m of t. If it is getting a signal like a cos 2 pi fct plus b sine 2 pi fct, then the output will be square root of a square plus b square. All these outputs we are talking about envelope detector. All these outputs we are talking about envelope detector. Okay. And it will work only for mu less than or equal to 1. It will work only for mu less than or equal to 1. Mu greater than 1, then phase reversal occurs. That's the necessity. We go for the next method of modulation, DSBSC, double sideband suppressed carrier.